All right, you guys, this is the review for the final for Unit 4. Like I said in the other videos, go through. My advice would be go through this, watch me do it, then spend maybe 20 minutes going through Unit 4 by yourself, okay? Just because this is my guess of what's going to be on there, but there could be more. Okay, so here's a question. I really don't like it at all. Came up on the final last semester. Here's what it says. It says some row operations have been applied to A, meaning matrix A, to obtain this matrix. 1, 2, negative 4, 0. Negative 1, negative 5, 0, negative 1, 0, negative 10, x, and y. Find x and y. Okay, so you have to try to get in this person's head and figure out what they're doing. So, they tried to get this to be a 0. Well, they did turn that into a 0. So, one thing they could have done is negative 2 times row 2, positive 2 times row 2, plus row 3 becomes my new row 3. So let's see if that puts a 0 there and a 10 there. So if you go 2 times row 2, you get negative 2, negative 10, 0, negative 2. And then put row 3 right underneath it. Add those together and you get 0, negative 16, negative 7, 4. So I know that's not it because that's not a negative 16. So that was not the right option. So maybe they used row 1. So go negative 2 times row 1 plus row 2, plus row 3 becomes my new row 3. Okay, so negative 2 times row 1 is negative 2, negative 4, 8, and 0. Put row 3 right underneath it. Add those together and you get 0, negative 10, 1, and 6. So that's it because the zeros matches, the negative 10s match. So your answer is x must be 1 and y must be 6. Okay, so I don't know. I just don't like it. I'd rather you just be able to do it by yourself and not figure out what somebody else did. So I think it can be a little tricky. Okay, question number 2. Solve by Gauss elimination / row operations. And I think it may have said row operations / Gauss elimination, same thing. So basically what that means is you can use Gaussian or you can use Gauss-Jordan. Well, Gaussian is the easier of the two because you don't have to go all the way to the identity. Gauss-Jordan is tougher because you have to go all the way to the identity. So I would definitely use Gaussian. Okay, yes, Gaussian. So go 2x plus y minus z equals 3, negative x plus 2y plus 4z equals negative 3, and x minus 2y minus 3z equals 4. Okay, so I'm going to use Gaussian. So 2, 1, negative 1, solid line 3. Next one, negative 1, 2, 4, negative 3. Next one, 1, negative 2, negative 3, 4. So Gaussian is just the one where you just have to get the 3 zeros. So the first thing I need to get is a 0 right there. You guys, do you notice right here how your top number, that 2, is not a 1? So I know it's strange, but I think the first thing that I would do is I would say row 1 becomes row 3 and row 3 becomes row 1. So I would switch those rows. The only reason I say that is because if you don't have a 1 in that corner, it makes it tougher. And I don't want to get into a tough situation. So I'm going to switch, okay? Now I'm going to get a 0 right there. Well, that's going to be easy. I'm just going to go row 1 plus row 2 becomes my new row 2. So row 1 doesn't change. Row 3 doesn't change. Add row 1 and row 2 together and you get 0, 0, 1, and 1. Now this one I'm going to be kind of all over the place because now I notice I've got 2 zeros. Well, that's what I'm supposed to have in row 3. So I'm going to say row 2 becomes row 3 and row 3 becomes row 2. So I'm going to switch those. Okay, so row 1 doesn't change. I'm going to switch row 2 and row 3 and I get 2, 1, negative 1, 3 up there, 0, 0, 1, 1. Now the only thing I need now is just to get a 0 right there. So I'm going to go negative 2 times row 1 plus row 2 becomes my new row 2. So row 1 doesn't change. Row 3 doesn't change. Negative 2 across the top is negative 2, 4, 6, negative 8. Write row 2 underneath it. Add those together and you get 0, 5, 5, negative 5. And I'm done with my matrix. So remember you start at the bottom right here. So that means no x, no y, 1z equals 1. Now go to the row up above that. And it's solved for z, so I don't have to do anything. Row up above that is 5y plus 5z equals negative 5. Put a 1 in for z. 5y plus 5 equals negative 5. Pull your 5 over. 5y equals negative 10. Divided by 5, y equals negative 2. Then I go to the very top row, and that is x minus 2y minus 3z equals 4. Y is a negative 2 and z is a 1. So it's x minus a negative 2 is a, a negative 2 times a negative 2 is a positive 4. On the z, negative 3 times 1 is a negative 3 equals 4. So that gives me x plus 1 equals 4. Pull that over, x equals 3. So my answer is 3, negative 2, comma 1. Absolutely checkable. Store them in, plug them into the original, and it would be crazy not to check that. Okay? Question 3. A is 1, negative 1, 1, 0, negative 2, 1, negative 2, negative 3, 0, and they want you to find the inverse. Okay, so to find the inverse, you put the A on the left, you put the identity on the right, and then you turn the left-hand side into the identity. Okay, so the first thing I need is a 1 right there, done. Second thing I need is a 0 right there, done. So the third thing I need is a 0 right there. So I'm going to go 2 times row 1 plus row 3 becomes my new row 3. Okay, so row 1 is not going to change. Row 2 is not going to change. Distributed 2 across the top, 2, negative 2, 2, 2, 0, 0. Put row 3 underneath it. Add those together and I get 0, negative 5, 2, 2, 0, and 1. This is a good one to do because it's going to be kind of tough. The next thing I need is to get a 1 right there. That would be dividing by negative 2, but I'm going to create fractions. So I'm going to skip that and I'm going to turn that into a 0. I know that I cannot use row 1 because this 1 is going to mess up this 0. So I can't do it. So how do I get rid of a negative 5 using a negative 2? Well, I'm going to have to turn them both into 10s. So I'm going to go negative 5 times row 2. That's going to turn that into a positive 10. Plus 2 times row 3 becomes my new row 3. So sometimes you have to involve both of those equations, okay? So row 1 doesn't change. Row 2 doesn't change. Multiply negative 5 across row 2 and I get 0, 10, negative 5, 0, negative 5, and 0. Multiply 2 across the bottom, 0, negative 10, 4, 4, 0, and 2. Add those together and you get 0, 0, -1, 4, -5, and +2. I'm still avoiding that 1 in the center and it's fine. Okay, the next thing I need is a 1 right there, and that's going to be easy because I can just change the sign. So a negative times row 3 becomes my new row 3. That's how you write up, change the sign. Okay, so row 1 doesn't change. Row 2 doesn't change. Change the sign to row 3, 0, 0, 1, -4, +5, -2. The next thing I need is a 0 right there. I could do row 2 minus row 3 or row 3 minus row 2. It doesn't matter. I'm going to go row 3 minus row 2 becomes my new row 2. Okay, so row 1 doesn't change. Row 3 doesn't change. Row 3 minus row 2, 0 minus 0, 0. 0 minus a -2, that's 0 plus 2, which is a 2. 1 minus 1, 0. -4 minus 0, -4. 5 minus 1 is a 4. -2 minus 0 is a -2. Now, look at row 2. If I tried to turn the 2 now into a 1, oops, I meant to highlight that. If I meant to turn this guy right here, sorry, I'm trying to erase that. Okay, well, that's a -2. There we go. I gotta wait for the highlighter to go away. Anyway, that's a -2 right there. Okay. No, it's a +2. Yeah, that's a +2. Okay, so anyway, this is a +2. If I want to change that to 1, I would divide by 2, and now I'm not going to have fractions. So as soon as I recognize that I'm not going to have fractions anymore, then let's do it. So I'm going to go row 2 divided by 2 becomes my new row 2. So I'm just going to blow that off until it's safe to do it. Okay, so row 1 doesn't change. Row 3 doesn't change. Divide row 2 by 2 and you get 0, 1, 0, -2, 2, -1. The next thing I need is to get a 0 right there. Okay, use row 1 and row 3. If you did row 3 minus row 1, it would turn this 1 into a -1, which I don't want. So I'm going to go row 1 minus row 3 becomes my new row 3. Okay, so row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 3, 1 minus 0, 1. -1 minus 0, -1. 1 minus 1, 0. 1 minus a -4, that's 1 plus 4, which is a 5. 0 minus 5, -5. 0 minus a -2, that's 0 plus 2, which is a 2. The last thing I need is a 0 right there. So I'm going to go row 1 plus row 2 becomes my new row 1. Okay, so row 2 doesn't change. Row 3 doesn't change. Add my rows 1 to row 2 and I get 1, 0, 0, 3, -3, and 1. And I'm done. My inverse is the right-hand side. That's what I would box or highlight, and I'm done. Okay. You know, I should have done this at the beginning, and I'm sorry. Just a quick summary of the methods. Okay. So we have Gaussian. We have row echelon. We have Gauss-Jordan. We have Cramer's rule. And we have matrix algebra. So not only do you have to remember how to do them, you have to know the difference. Okay. So Gaussian, Gauss-Jordan, and row echelon all begin the same. Okay, so here's how they begin. Matrix A on the left, that's the left side of the equation. Matrix B on the right, that's the right side of the equation. So those all begin the same. Okay, then you manipulate it. Okay, now here's how I remember. I know it's weird, but this is what I do. Gaussian and Gauss-Jordan both begin with the G. So they both begin the same, A on the left and B on the right. Gaussian and Gauss-Jordan only need one I in the problem, letter I. So this Gaussian already has the I. So I don't need to go to the identity. Gauss-Jordan does not have a letter I in it. So since it's missing the I have to get my I right there. So I go all the way to the identity, and on the right is the answer. So then what's Gaussian? Gaussian is the one that you just have to get those zeros. All these dots right here are just numbers, and then you just work from the bottom up. What's row echelon? Well, it's exactly like Gaussian, except you have ones in the diagonals. All those dots are numbers, okay? Cramer's rule is kind of its own thing. That's the one where you find the determinant, and then it's like, 1, 2, negative 1, 3. Then you do the cross multiply, 3 minus a negative 2, that's 3 plus 2, which is 5. You can get a 3 by 3. So that's a totally different thing. And then matrix algebra is the one where you find the inverse. So you put matrix A on the left, the identity on the right, manipulate it so you have the identity on the left and the inverse is on the right, and then you take the inverse and multiply it by B, and that's your answer. Okay, so you have to know the difference between these methods. If they ask you to solve using Gaussian and you use a different method, you're not going to get any points at all. Okay, so you have to remember the difference. Okay, here's question 4. I pretty much just did this. So find the determinant. So negative 2, 3, 4, 0. So this is a part of Cramer's rule. So cross multiply, negative 2 times 0 is a 0, minus 4 times 3 is 12, 0 minus 12 is a negative 12. So that's a determinant. You could also have to find the determinant of a 3 by 3, which is much more complicated. Okay, here's number 5. So we have a 3 multiplied by a matrix, and then you have a negative 4 multiplied by a matrix. But I need to understand that this and this are being subtracted because there's a sign in between, so they're not being multiplied. Okay, so remember, what I want in the center is always a plus. Okay, so take the 3 and distribute it into the first one. Negative 3, 0, 6, and 15. Then take the negative 4 and distribute it into the second one, and you get 8, negative 12, negative 4, negative 24. And now you just combine those numbers. So negative 3 plus 8 is 5, 0 minus 12 is a negative 12, 6 and negative 4 is a 2, 25 minus 24 is a negative 9. There's your answer. Okay, question 6. Find the form of the partial fraction decomposition. Okay, so your problem is, might be f of x, I'll probably say f of x or something like that. F of x equals 2x plus 1 over x to the third plus 8x. So basically they want you to split it into 2 fractions. So write down the original problem, factor the denominator. Take out an x and you're left with x squared plus 8. So now I'm going to write it as 2 separate fractions, the first denominator being an x, the second denominator being an x squared plus 8. So that's what my answer is going to look like. And then I just have to figure out what goes on top of those. Okay, so the x is easy, it's just an a. If you have a fraction with a squared that's added or subtracted to something and it won't factor, just like that, x squared plus 8 won't factor, then you must set it up as bx plus c. If you don't put bx plus c, you're not going to get it right. Okay? Now, I'm going to multiply by the original denominator. So just take a second and multiply each of those by x times x squared plus 8. Okay, now this x cancels with that one, that x squared plus 8 cancels with that one, and you have 2x plus 1. On the right, this x cancels with that x, distribute the a, and I have ax squared plus 8a. Next one, this x squared plus 8 cancels that x squared plus 8, distribute the b, and I have bx squared plus cx. Now let's write an equation with just the squareds, the x squareds, but drop the x squareds. So on the right I have a plus b, on the left I have no x squared, so I put in a 0. Now let's do the x's, but drop the x's. So you'd have 2 equals c, and that's awesome because I already have a variable, which makes it so much easier. Now let's do constant, meaning no x at all. 1 equals 8a. So right now I know my c is a 2. So I'm going to go plus c. Okay, so that guy's done. If I divide by 8, I know that a is 1/8. I'm going to put that right there. Then if a is 1/8, then I have 1/8 plus b equals 0, and I get b equals negative 1/8, and that goes right there. Okay, now this is also checkable. So I want you to grab your calculator, and we're going to check it together. Okay. I'm going to choose a random value of x to put in. I am not going to choose 0 because I have an x in the denominator. So I'll just do like a 1. I'm going to go 1 store enter. I'm going to put the original problem in my calculator, adding parentheses around the top and the bottom. So go parenthesis, 2 membar enter plus 1, close it, divided by parenthesis, membar enter, raise it to the third, plus 8 membar enter, close it, enter, and I get 0.3 repeating. So if I get 0.3 repeating down here, then I know I'm right. Oh, see that plus c? That should say plus 2 right here in my answer. Sorry about that. Okay, so add parentheses here, here, and here, and see if you get 0.3. So go parenthesis, 1 divided by 8, close it, divided by membar enter, plus parenthesis, negative 1 divided by 8, membar enter, plus 2, close it, divided by parenthesis, membar enter, x squared, plus 8, close it, enter, I got 0.3. So there is no question in my mind that I got that right. Okay? Okay, here is number 7. Solve this system algebraically. Sometimes Weber puts on there, no points will be given for guess and check, meaning you can't just start plugging numbers in and find something that works. Okay, I cannot use elimination because the x's are squared on the second and not in the first. Same thing with the y's. So, sorry, I know I'm going to have to use, weird, I'm moving and this thing is not moving. Wow, I'm stuck clear back here. Okay, so what I'm going to do, so my screen, my projector is not showing what I'm doing. It's like frozen. So I don't know if I'm recording my computer or if I'm recording my projector. I hope it's the computer because the computer's fine. So if everything's fine and my recording is good, then I'm going to pick back up at question 7 and I'm just going to do a second recording, okay? Because I don't want to sit and waste another 20 minutes. So, you know what? I think it's going to take me like 10 more minutes. So I'm going to do it. I'm going to hope that it's recording the right thing. Okay, so question 7, I have to use substitution. I don't want to solve equation 2 for x or y because they're both squared. So if I solve equation 7 for x, then I get 2x equals 1 minus 3y divided by 2, and I get x is 1 minus 3y over 2. Okay. Now, I could have also solved for y. So now I'm going to go in here and put that for x. So I have 4 times 1 minus 3y squared over 2 squared plus 9y squared equals 5. Now I'm going to have a 4. When I square this, so easy, 2 squared is 4, and 1 minus 3y needs to get FOILed. So when I FOIL that, I get 1 minus 6y plus 9y squared. And then I have plus 9y squared equals 5. So those 4's cancel out, and I have 1 minus 6y plus 9y squared plus 9y squared is equal to 5. Then I clean this up, and I get 18y to the second minus 6y. The 5 comes over and becomes a negative. Minus 4 equals 0. Okay? Now, I don't think this is working out how I wanted it to. Okay, let's see if it works out. I do not think it is. Let me do something really quick. Okay, I'm going to change the problem. So all I'm doing very easily is I am changing this 5 right here to a 7, the original problem. So then this is going to be a 7, and this is going to be a 7, and this is going to be a 7, and when you pull it over, it's a minus 6. Okay, so then when I take out a 6, I'm left with 3y to the second minus 1y. And now it won't factor because I put a 2. Give me 2 seconds. Okay, you're going to kill me. I just don't want to redo it. Sorry, guys. So this was originally a 5, and we're going back to a 5. So this is a 5. This is a 5. This is a 5. This is a 5. That's a minus 4. Okay, so it was going to be fine, and I thought it wasn't. Okay, so that's where I'm at. Take out a 2, and I'm left with 9y to the second minus 3y minus 2. Then I factor it, and it goes to that. So now I know y is a negative 1/3 and a positive 2/3. So I'm going to come over here, put a negative 1/3, come right there, put a positive 2/3. Now the best place to plug it in is right there. So it's x equals 1 minus 3 times a negative 1/3 divided by 2. I really think you should get your calculator and put that in. So just go 1 minus 3 parenthesis, negative 1 divided by 3. When you do that, you get a 2. So that's a 2 over 2, which is a 1. Do the next one. X equals 1 minus 3 times 2/3 over 2. So that is going to give you a negative 1 over 2, and those are your 2 answers. Totally checkable. Store them in, plug them into those, make sure it works out. Okay? All right, here's question 8. A sub 1 is 2. A sub n is 3 times a sub n minus 1 plus 6 times a sub 5. Find a sub 5. So this is a recursive sequence. The biggest thing you need to know about this is that a sub n minus 1 means the previous term. Okay, so a sub 1 is a 2. So to find a sub 2, you follow that formula, which is 3 times the previous term, which is a 2, plus 6. That gives me a 12. Do the next one. A sub 3 is 3 times the previous term, which is 12, plus 6. That gives you 36 plus 6, which is 42. Do the next one. A sub 4 is 3 times 42 plus 6. So if we go 3 times 42 plus 6, I get 132. This is the one they're looking for, a sub 5. So it's 3 times 132 plus 6, and you get 402, and that's your answer. Okay, here's number 9. Find the sum. Okay, so one big thing that you must do is you must notice that it is an infinite series. The reason it's an infinite series is because you've got the dot, dot, dots. So the only way that this infinite series, if the sum can even be found, is if it converges. And the way you decide if it converges is you find the ratio. Okay? So look at my signs, they're alternating, positive, negative, positive, negative. So I know my ratio has to be a negative. When you're deciding if it converges or diverges, don't even think about the sign of the ratio. It's just the number that you're caring about, okay? So look, do you see how all the tops are 3s? So I know my top of my ratio is going to be a 3. And this is a 3 over 1. Remember, ratio means multiply. This is a geometric sequence. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So now I can see that I'm multiplying by a negative 1/2. 1/2 is smaller than 1, so I know it converges. So I can totally do it. So the sum of an infinite series is a over 1 minus r. So the sum of this infinite series is a, which is the first term, 3, 1 minus a negative 1/2. Okay? Well, if you grab your calculator and go 1 minus parenthesis, negative 1 divided by 2, you get 1.5. So this is 3 divided by 1.5. And if I go 3 divided by 1.5, enter, I get a 2, and that's my answer. Okay, last question, number 10. Okay, find the term that contains x to the 12th in the expansion of 3x to the 2nd minus 1 to the 13th power. Okay, so I could write the whole thing out, but I don't want to do that because I'm just looking for one of those 14 terms is what I'm going to get from that. Okay, so watch what you do. Remember this number right here is a 13. That always goes there. And do you see how this is 3x squared? Put parentheses around it. And then the next term is a negative 1. Put parentheses around it. So the biggest thing that people don't do is they don't put parentheses. Okay? I know that I want my x to be to the 12th. So if this is an x squared, what would this exponent be to get a 12th? Well, it would be a 6. Because power to a power, you multiply. 6 times 2 is a 12. Well, if that's a 6, then you have to figure out what this number is underneath the 13. And you say 13 subtract what gives me 6. That's a 7. Then once you know that that's a 7, then I know that that's a 7. So there's your setup, okay? Now let's find it. So to find this right here, you're going to go 13 factorial divided by 7 factorial times 13 minus 7, which is 6 factorial. And then right here, the 3 needs to be raised to the 6th power, which is 729. And the x is to the 2 times 6, which is 12. And negative 1 to the 7th is a negative 1. So let's find that factorial stuff. So everybody go 13, PRB, right, enter, divided by parenthesis, 7, PRB, right, enter, 6, PRB, right, enter, and I get 1,716. That's going to be multiplied by 729 x to the 12th times a negative 1. So go 1716 times 729, and I get 125. It's a negative, by the way, because of that negative 1. 125,0964. So it's 1,250,964. They want the entire term. If they said just coefficient, that would be your answer. But they want the term, so the x to the 12th goes with it, and that's your answer. Okay?